Let us continue our discussion about simplification of Boolean algebra. Let's have this problem. Problem 1. Simplify the following expression to a minimum sum of products. Only individual variables should be complemented. No shared negation is allowed. So let's have this example. Not of xy naught plus not of x naught plus y added to z. As you can see in this equation, we have a shared negation for the first term and also on the second term. So we need to separate the negation of these two terms. So if we want to separate the negation, only the De Morgan's law could be implemented for that. So using De Morgan's law on the first term, we could rewrite it as x naught plus y naught naught. So just a review of De Morgan's law, and will become or, copy, and then distribute the negation. So that's why we have x naught plus y naught naught. Okay? And in this first term, we have double negation, and we all know that double negation we can cancel it. So we could rewrite it as just y. So we have x naught plus y for the first term. And if you're going to analyze the first and second, this first term is actually negated on the second term. So therefore, we could remove the negated version of the first term using theorem number 5. So the result will be x naught plus y plus z. Is this simplified? Yes. Do we have a shared complement or not? We don't have. So therefore, this is the final answer. Problem 2. Same task. Get the minimum sum of products and no shared negation. So our equation is a plus b added to cd plus not of a plus b. So let's analyze the given equation. What can you say about the first and the second term? Actually, the second term is part of the first term, but in a negated version. So a plus b not is basically a plus b. So therefore, we could implement theorem number 5 so that we could remove a plus b on our first term. So now we have cd plus not of a plus b. But unfortunately, in our second term, we have a shared negation. So we need to separate it using De Morgan's law. So now we have a naught b naught for the second term, or will become and, copy, and then distribute the negation. So the final answer for this problem is CD plus A naught B naught. Problem 3, same task. Our question is x plus y naught added to z plus w negated, and the whole second term is negated, and also the whole expression is also negated. Okay, so we have 3 levels of negation for this problem. So I'm going to evaluate the outermost negation. So let's implement De Morgan's law on this level of negation. So therefore, our first term is x, and our second term will be this part of this equation. So, or will become and, copy, and then distribute the negation. So not for x and not for the second term. And what can you say about the second term? We have a double negation here. So therefore, we could cancel it. So we have, on the second term, y naught added to z plus w, and this z plus w is under a NOT gate. So this is the only part of the equation which we have a shared negation. So we could implement De Morgan's law to have this equation. X naught, Y naught, Z naught, W naught. Is this minimum sum of product? Yes. Do we have a shared negation? No. Therefore, this is our final answer. Problem 4. Same question, same task. Get the minimum SOP. There should be no shared negation. So our equation for this problem is not of A naught plus B naught plus 2 not of A naught B naught C or 2 C naught D. We have two options in simplifying this equation. One is we're going to evaluate first each term and then evaluate later the main negation. Or we're going to evaluate first the main negation and then later we're going to evaluate the different terms. So for me, I'm going to evaluate first the main negation. So I'm going to use De Morgan's law to have a separate negation. So first, I'm going to identify my first term and second term. So for me, my first term for the De Morgan's law will be A naught B naught, and this term will be my second negation, second term. So when we implement De Morgan's law, first term will be rewritten as A naught plus B naught and double naught. Or will become and, copy, and then have a shared negation. And we all know that double negation can be removed in our equation. So therefore, our first term will be A naught plus B naught. Now, we are ready to simplify the second term. So let's evaluate the second term using De Morgan's law. We have A naught B naught C, double negation, or will become and then not of C naught D. And we all know that again, double negation, we could remove it in our equation. Therefore, we have A naught B naught C for this term. Now, we're going to evaluate this negation, shared negation between C and naught and D. So using De Morgan's law, we could rewrite it as C naught naught plus D naught. And again, double negation could be removed in our equation. So we have C plus D naught for this term. Now, we're going to combine terms. So first term and second term, let's combine it using distributive law. So we have A naught B naught C, and second term, A naught B naught C. Third term, just copy. And we all know that A naught is just A naught, B naught and B naught is also just B naught. So we have A naught B naught C for the first term, A naught B naught C for the second term. And the first and second term is the same, are the same. Therefore, it could be rewritten as A naught B naught C. So next will be, we're going to distribute A naught B naught C to C plus D naught. The result will be A naught B naught CC plus A naught B naught C D naught. And we all know that CC is just C, so it could be rewritten as A naught B naught C plus A naught B naught C D naught. And the first term is actually a part of term 2. So therefore, we could apply theorem number 5 to eliminate the second term. So we have the simplified version of this equation, and it's equivalent to A naught B naught C. That will be our final answer.